So everybody thinks they know what falling number is, but you don't really know what a falling number is until you've actually looked at the instrument and understand a little bit about how it works and what the numbers actually mean in real life, and to be able to interpret those. So here we have the instrument itself, which is essentially a vat full of boiling water and a gizmo that stirs and then measures how long it takes for a weighted probe to go down through a plug of starch. And the end of the probe looks a little bit like the logo of a major German luxury car manufacturer, which allows the thing to slither through. If it was solid, it wouldn't go anywhere, it'd just sit on the top. This way, you get a very measured, consistent descent. So here we have 2 samples of ground wheat that we're going to measure today. So we have put in 25 milliliters exactly, neither more nor less, into the tube. There's about 7 grams of wheat flour in there, and that plus 25 milliliters is going to be the suspension that forms our starch slurry. It's kind of like, when you get down to it, much the same as putting flour into a gravy mix. It's the same exact principle where you add starch into a gravy mix, and what it does is it thickens, and this is just what's being measured here, is how thick does the water and starch get in this boiling water vat. So they go down inside, and we push our start button, and it counts for a few seconds, and then it proceeds to start mixing them. So the starch and flour slurry are down in here, and it's being boiled, and as the temperature is rising, the starch begins to gelatinize. Same thing as throwing the flour or cornstarch into your gravy, a little heat, a little water, and you start mixing around, it starts thickening up. Same thing's going on in here. And what it's doing is measuring just how thick this slurry becomes. And at the end of 60 seconds worth of mixing, it's going to stop and put the plunger, the weight, on top of that bunch of starch, and it's going to just wait and count how many seconds it takes for the plunger to fall, hence the name falling number. And you never get a falling number less than 60, because you can see it's counting right now up to 60, and as soon as it hits 60, the test actually begins. So you never see a falling number lower than 60. It just isn't the way the instrument works. So here we go to the stop, and you can see the one of them, the sprouted side, is already beginning to make its way down slowly, slowly. So I expect it'll probably hit the bottom in about 100 and some seconds, which would indicate a very sprouted wheat sample. The other side, which is sound wheat, you can see hasn't moved a bit. And in fact, it's going to probably stay there for 5 to 7 minutes just hovering, and that would indicate a very sound grain sample. So down, down, down it goes. No starch gel is being formed. There's not a whole lot of resistance to that little weight descending down through it. And when it gets to the bottom here, it's going to trigger a stop. The machine will sense that and beep. It stops, and it's got your count right over there, 106 seconds. So there's your falling number. You've got sprouted wheat. And that's not what anybody likes to hear, but it's part of what this instrument detects. A wheat plant is not so much interested in making a good loaf of bread or a cake or a cookie for us. What a wheat plant wants to do is make a new wheat plant. So when a wheat kernel, after it's ripened in the field, is standing there, what it really wants to do is sprout and make a new plant. So when water comes along, say from a passing rainstorm or something, it comes on and starts to generate an enzymatic cascade. The wheat plant thinks, okay, the seed thinks it's time to grow, let's go. So it begins producing some enzymes which start turning the starch into sugars, because the small wheat plant needs to have sugars to grow to get its leaf up to where it can start photosynthesizing. So that's where it gets its energy from, is the conversion of starch into simple sugars. And to do that, it gives the plant enough oomph to grow until it can get going. And that's all the plant is really interested in. So when the starch is degraded, it turns into sugar, which is fine for the wheat plant, not so good for end products. And this is exactly why. A nice sound wheat will make a nice sponge cake, very nice, robust, a lot of volume here. looking very good. So it's a very nice sponge cake. However, if you try to make the same sponge cake with sprouted wheat, what you get is this, a very much degraded, flat, can't hold its volume, and very gooey and sticky down here at the bottom. And that's because you don't have starch anymore. What you have is sugar, which with the water in the formulation for the cake makes a syrup. And you can see that you're not going to have a lot of happy consumers when they're expecting this and they're getting that. It's a commercial and production disaster. The mills don't like it because they aren't interested in providing second-rate food to their clients and the buyers, but sometimes that's what you get. And so we have to be very, very careful about pre-harvest sprouting when it gets into the marketplace. So when I talked about the starch, here's my little visual on what I mean by that. Starch is nothing but glucose, which is a sugar, put end to end to end into great long strands, great long polymers. And that's what makes up a starch granule. And you can see that if you're trying to form something structural like this, you got enough structure here to do something. But the enzymes that form during sprouting act very much like scissors. So here's my enzyme, and it starts attacking pretty much at random starch granules, starch molecules, and it just hacks and snips and chops at random. And suddenly you've got a bunch of this just hacked up pieces instead of these long polymers. So when you get this, you're trying to build structure off of that when you really need long polymers. So the enzymes that occur during pre-harvest sprouting lead to very much degradation of the end product quality, and it has to be very careful. And these enzymes move a lot faster than my little scissory enzymes here, because they will convert 3,000 to 5,000 of these bond cleavages per second per enzyme. So each molecule of enzyme you have is going to go through 3,000 or 5,000 of these clips per second. You get a whole bunch of enzyme in there, and your starch disappears and is very rapidly degraded. Plants are very efficient at doing this because it's what they need to grow and to move along. 364 seconds on the sound wheat, so it's just now come in. So there it is, 360 seconds versus 105 or 6. Very much sprouted, very much not sprouted. So when we do this, you can see the gooey mess that is inside of these tubes. And you can see this one, the stuff is just welling around. This stuff is holding pretty steady. This is just liquid, just pure liquid. And so this is the difference between a sound wheat and one that's sprouted. This is just nothing but small sugars. That's long chain sugars, and that's what we just measured with this test. The falling number is certainly not the say-all and end-all, because it does have some technical limitations on the value you get out of it. But it's part of the system now. It just behooves one to know exactly what it's telling you via this instrument and these readings, and to be able to take best advantage yourself of the way the system is working.